how do you get the full picture, the big picture, so that engineering teams, platform engineering teams, FinOps teams can work on the same scorecard, same visual, and have this one common consistent look on what's going on across the enterprise.
Welcome to It's About Data, episode 39. We're joined by Dinesh Chandrasekhar to discuss his recent report on architectural intelligence.
Well, hello, everybody. Uh, we're here today with a special guest and a fellow Data Gang member, Dinesh Chandrasekhar. He's the principal of Stratola Research. This is someone who's spent over 30 years, I was going to say almost 300 years, but over 30 years in both the product and the marketing sides in the industry. He is now an independent analyst and one of my fellow Data Gang members. And Dinesh, you've recently come out with really quite an opus, which was basically comes under the title of Architectural Intelligence. You've released publicly, I think, about a 14-page report that I've downloaded, and I'm still trying to figure it out. This is pretty, profound stuff, and that's what we'd like to talk about with you today.
Yeah. So what I've seen in my career of 300 years, as you said, having worked at like observability companies and like other types of software data platform companies, is that we all function in units and have like our own scoreboards as teams. We don't have like a unified team scorecard where we all function towards one common goal. So if you look at observability vendors, for example, their goal is reducing MTTR, solving or troubleshooting, doing root cause analysis, and all that kind of stuff, which they do from that perspective of purely addressing what's going on in the system, what kind of a trouble is happening, and how do I solve it. But if you look at the bigger picture, there is also this notion of what does that cost to the enterprise? That particular service down, what is it costing? Can I kill that service? If so, what is the impact analysis on the rest of the organization? How will engineering teams react to it, and so forth? So there is a whole series of questions that don't get addressed because you don't have the bigger picture. So that is what I'm trying to solve with architectural intelligence, by talking about how do you get the full picture, the big picture, across the organization, so that engineering teams, platform engineering teams, FinOps teams, everybody else can work on the same scorecard, same visual, and have this one common consistent look on what's going on across the enterprise.
It sounds a lot like, I mean, just a very general impression before Matt jumps in. My general impression is that what you're talking about is the siloing that we've always had. And it's
Yeah.
nothing, and of course, we all know there's nothing new there.
Yeah.
But you're talking about an interesting approach that basically is taking advantage of something that we're really starting to get a lot more into with regard to, for instance, like, with AI applications, especially, which is basically in knowledge graphs. So can you talk to us about that in terms of the role that this is playing here to provide more of that, in context view?
Yeah. To me, the connective tissue is enterprise architecture, right? So if you look at an organization, one thing that is clear and telling about what is happening within that technology is how are the different components connected, where are they existing, what platforms or what systems are they running on, what cloud or container deployments have happened. So everything has got a connective tissue there. While it is not like clearly depicted, the architecture is the one that kind of connects all the glue, or connects it as a glue. More importantly, the context in which they are connected is more important for understanding the big picture. So if you look at, let's say, a code base of a software platform, and understand how each and every code is connected, where the different code deployments are deployed, and how or which particular business owners own specific parts of that different code bases, it'll kind of give you the big picture. It'll kind of give you the full picture of who's connected to what and all that. So doing impact analysis, doing dependency analysis, everything becomes more clear when you start looking at from an architecture standpoint rather than like only one siloed viewpoint. So knowledge graphs kind of have this underlying ability to start connecting these different dots, not from just purely a structural context, but purely from nodes and distances and all that kind of stuff. Makes it more meaningful to say this particular business owner has control or ownership of this particular code base, which is deployed on this particular server, which has dependencies on these particular microservices, which are owned by this particular department, and so forth. So you can completely connect the dot and get that connective picture of the entire enterprise using knowledge graphs as kind of like an underlying technology.
So, in your white paper, obviously, you both discussed that this is a long-standing issue. This is not really a new issue, but in the white paper, you talk a lot about AI as a growing driver for security problems and uncontrolled spending. So tell us more about how AI changes this conversation, having AI in enterprise architectures.
So when you today have a development team build out a code for a particular set of business requirements, you have control and visibility on who's building what. And then as organizations become bigger, now suddenly siloed development teams start building up like different things, and you suddenly start losing control. What's happened with AI is now that everybody can generate like different types of like code bases very, very instantaneously almost, because of the code generation capabilities. So suddenly code generation is no longer having that staggered way of like growing. It's now exponentially growing, which makes it hard to even like get control and visibility of who's building what kind of impact does it have on like other parts of the enterprise and so forth. So that's the real problem that I'm talking about there, and it also leads to security issues as well, because nobody has like time and ability to like audit suddenly like 300,000 lines of code that it just got generated by AI. And so without those kinds of structure and governance and controls in place, it suddenly becomes like super complex to like understand what kind of security gaping holes we have introduced as a way of like these AI generated code bases that now snuck up into our production deployments.
So, question I have here is how do we put these pieces together? I mean, again, what you're talking about, and this is why this is really rank so true, is that you talk about, for instance, like the site reliability engineer is going to be looking at, is this site up? Someone's looking at the cost, side. It's going to be saying like, are we spending too much, for this, for this additional nine of availability? I mean, I'm grossly oversimplifying. But I guess what I'm asking here is how do we bring this all together? I mean, obviously, we talk about knowledge graphs, but the thing is that, one of my impressions this year is I remember we got very excited about GraphRag at, the early part of the year. And it's one of those things which is on a whiteboard. And yet, knowledge graphs, just getting there is still pretty hard to do. So tell me basically, what would you think would be kind of a process to how to start to put this sort of visibility together? Take us through like maybe some baby steps.
Yeah. So first off, everything starts at almost a code base level, in my opinion, because that's where everything starts. Particularly, as I said, with the AI code generation as well, the complexity starts growing at that level. So if you can come up with like a map automatically of how these different things are connected, and then start connecting where those different individual services are deployed, how they are connected and so forth. Now you've solved like this other part of the visibility layer that has been like almost invisible for the observability vendors, for example. So the SRE solves for which particular service is down, why it is down, or something like that. They do that, but they do not understand what the cost impact is, what the dependency impact is, and so forth. So that's the part that I'm trying to solve with this, right? So if you bring these two worlds together, now you suddenly have this big picture, right? So in order to do so, you leverage AI to look at the code base and start creating these levels of high level maps, and then have the ability to both go deeper down as well as like go up from that map to understand what other service components are related to this from a deep dive perspective, as well as like where these services are deployed, who's got the business ownership on this, and so forth from a bottom up approach as well. So you start off at the code base level is what I'm saying, and there are a
Mm.
couple of vendors that are starting to do something like this in this particular space, which I'm very excited about. And I think we'll start seeing this more in 2026 as this becoming kind of like this connective tissue for the larger enterprise.
I think one theme we've seen over and over again in this industry, be it data or enterprise IT, is that for a technology change to be successful, you also have to make organizational changes. For example, microservices, both a technology outlook and a team outlook, for better or worse, right? People are still debating this. But from your perspective, in conjunction with these technology changes, what organizational changes would you like to see to allow more coherence in how we manage workloads and services and AI and all this code getting deployed?
Yeah, I think there is fundamentally a change that is required at a DevOps level, right? So you need to start introducing newer ways and newer controls in terms of code generation, code auditability, code explainability, everything, right? So you need that in place, which is currently non-existent almost in a lot of enterprises, because there is a lot of shadow AI organizations that are emerging. $20 can get you a tool that can immediately start, producing code, and a week later, that code is like running in production without like anybody having like clear understanding of what that would cause down the lane, right? So that level of control and explainability is something that is lacking today, which needs to be introduced into the DevOps organizations. Second thing is a cultural thing of coming together and making sure that there are joint decisions made. And this is kind of the crux of the architectural intelligence paper as well, that today decisions are being made in silos and there are no joint decisions being made. If finance says, I want to cut down on 15% of the cost spending because the cloud bills or the infrastructure bills are like, really through the roof. And where do you go and figure out which services to cut? Right, that decision making is very hard to do because
Yeah.
you're not clearly, but as a finance team, you're not clearly like giving that visibility to say where do you want that 15% cut. You are not clearly saying which particular services are like costing that. And then in terms of direction as well, product ownership or like the software code ownership, you don't know who owns what to like cut down on which parts of the enterprise as well. So that joint decision making, that joint visual, that joint map, which will bring the enterprise together to make this joint decision making, is lacking as well. And that's a cultural thing to like imbibe. And as software vendors produce more tools in this architectural intelligence space, you will start seeing that kind of joint decision making will become more prolific going forward.
Now let's look at this from the other side, because usually the argument is, okay, we've got this technology, but we need to have the organizational buy-in.
Hmm.
So here we're really talking about what it takes organizationally. Let's go back to the technology side, because ultimately, basically, enterprises are not going to fashion their own sort of enterprise-wide observability tools. So the question is, we talk about the FinOps folks, the DevOps folks, the platform engineers. In the vendor community, and I'm not asking necessarily to name specific names in the vendor community, but from what area of the vendor community is going to be really going to be the logical impetus for this? In other words, the ones who will basically lay out, say, the equivalent of, let's say, like the lake house architecture, for essentially for observability.
Yeah. So there are a few areas where this can come up organically as well, right? So there are, as I said, a couple of vendors that are trying to come up with like platforms in the architectural intelligence space. But outside of that, observability vendors, for example, they have kind of a larger view of the organization from a code, from a deployment perspective, infrastructure perspective, and so forth. Now, what they lack is the FinOps side, right? So I think a couple of our other analyst firm vendors have also introduced the notion that observability vendors should start, considering cost FinOps as a capability to introduce or bring in as a part of the larger observability vendor umbrella as well. And I don't think that exists today. A couple of vendors have that kind of capability as a checkmark item, but it's not like quite well connected. And so to them, it's a low hanging fruit of bringing in that capability and start looking at this as an architectural intelligence capability. And then on the other side, code intelligence vendors, there are a lot of vendors that are generating code for like different types of organizations, and they have the ability to start producing visual maps. For example, if I wear a cursor, Lovable, or somebody like that, if I start looking at it more from an architecture standpoint and saying, okay, today you have deployed all these code blocks into GCP, and you are trying to like lift and shift this into Azure. What's the impact? What kind of changes do I have to make? What kind of databases do I have to adopt on the other side? What kind of code level changes do I have to make? What is the efficiency gain that I'm going to get? What is the cost impact that I'm going to get? Benefits that I'm going to get? So those are what I'm trying to say, that they have the ability to do so, by introducing this level of map and saying, okay, here's the efficiency. Do you want us to like move your code base from GCP to Azure or vice versa, right? So that kind of capability is something that they can organically produce as well. So there is definitely movement possible from like all different corners. Where that alignment happens is something that we'll end up seeing in the next year or so.
Okay, so next question. Anytime you see a movement like this, you need a way to exchange data between the different architecture components and the observability components, right? And standards have been an Achilles heel for the tech industry forever. So, is there any chance that we'll be able to see better standards around this type of observability? And how would we go about creating those?
That's a really tough one because I
Yeah,
don't have an answer. Right? It's not like
Mhm.
one person says something and the industry adopts. The
yeah,
industry has to come together. Like for example, what we're seeing with MCP is kind of a little bit of a revelation because
right.
it's not quite the standard yet. It still has like lots of gaping holes. It's not ready yet for prime time, but people are doing left, right, and center MCP this, MCP that. Has it become the industry standard? Yes, kind of from an adoption standpoint, but can it be a standard for like future innovations? It's questionable because it still has like those gaps that needs to be addressed. So I think it's over time you will see some kind of adoption like this that will pave way for a standard. Right now there are like standards bodies that are working on agent to agent communication, better things, better than MC and all that. So there are things that are happening. As I know, I'm on one of the committees as well. But I also see that for something like this that I'm pitching, it requires a lot more than just something as simple as an MCP. I think it needs to come from like all corners. Um, a simple thing such as like OTel, for example, open telemetry. This has been around for like a few years now. Observability vendors should have adopted it. Vendors or companies should have adopted it for instrumentation. It's very hard. What I see right now is there are a few vendors that are starting to say, while I'm generating code, I can actually have it, instrument the code as well with OTel. That makes it a lot more easier because this is something that I've been wanting. AI is generating code. That's like the best place for you to like plug in OTel instrumentation automatically, right? And then you push that into production, and suddenly like your entire code is like instrumentable, monitorable by all these observability vendors and so forth.
Dinesh, I very much, Matt and I very much appreciate you taking the time here to talk about a very timely topic. Certainly want to check in with you next year to see, kind of like right if you get work. No, but more specifically to see because this is definitely a very timely issue at this point.
Yeah, yeah. No, I appreciate you both taking the time to like do this over the holidays, and I wish you both like great, happy holidays, and thank you for taking the time to like talk about
Okay.
architecture.
Absolutely. And as a reminder, the name of the white paper is Architectural Intelligence: A New Paradigm for Enterprise Visibility in the AI Era. And we'll put a link to that in our show notes and check it out if you're listening to this. It's a really cool discussion with lots of great insights.
Thank you so much.